So the chapter 3 يا شباب is about the differentiation rules. So we have here like 10 sections. Most of them are about the differentiation rules. So in the first one, we will learn how to differentiate polynomials and exponential functions. What is the derivative of the constant function? What is the power rule, the constant multiple rule, the sum rule, the difference rule, and the derivative of exponential functions. I think we have mentioned in the previous class that the derivative of any constant is 0. If you have a constant function, so see here, it is free from x. It does not depend on x. Then its derivative, if you use the definition, it will be 0. Similarly, if f of x equals to x, then its derivative is 1. And you can use the definition also, because if you use the definition, this will be x plus h minus x. This will be cancelled, and you have h over h, which is 1. So the derivative of x is 1. And for the other power functions, we have mentioned this before for some functions like x squared or x cubed. The derivative will be 2x. The derivative here will be 3x squared. For x to the power 4, I showed you in the previous class that you can, of course, show that it is 4x to the power 3 by using the definition, by using limit of x plus h minus f of x over 2.8, the one that we have studied in 2.8. In general, if you generalize this, you will have that the derivative of x to the power n is n times n minus 1. The proof is in your book if you are interested in. Not only for any positive integer, it could be generalized to be for any real number. So if x here, it is raised to the power of any real number, then its derivative will be n times x to the power n minus 1. So you will just reduce 1 from the power. Let's have an example. For example, x to the power 6. Abdulaziz Ismail, what is x to the power 6? What is the derivative of it?
6x to the power of 5.
Excellent, ya Abdulaziz. Abdulaziz Al-Qahtani, what is the derivative of x to the power 1000?
I think it's 1000.
1000 x to the power 99. Yes. 999. What is the derivative of t squared or t to the power 4? Ya Abdullah Al-Harithi.
4t to power 3.
You are right. What is dr cubed dr with respect to r? What is it, ya Abdullah Saud?
3r to the power 2.
Excellent. This is easy but important. Now, look how we will apply these tricks when we have a function that is not directly x to the power. But you need to, before finding the derivative, it is easier to think about this one as x to the power what? 1 over x. You know that 1 over x to the power n, it is just x to the power negative n from algebra. So this is x to the power negative 2. When you differentiate it, it will be, this is a real number, so it will be negative 2. By using the rule, you know that the derivative of x to the power n, if you differentiate it, it is n x to the power n minus 1. So now what you will do, it will be negative 2, this is n. Now x to the power negative 2, you will subtract 1. So it will be negative 2 x to the power negative 3. It is polite to write it in the same form that you had at the beginning. So this is negative 2 over x to the power 3. So the derivative of 1 over x squared, it is negative 2 over x to the power 3. So easy. Similarly here, this one you will write it as x to the power 2 over 3. And then you will apply the rule. When you differentiate it, what will be the derivative? This is y. Now this is our y. The y prime will be 2 over 3 x to the power 2 over 3 minus 1, which will be 2 over 3 x to the power negative third. That's, you can write it as 2 over 3 times 1 over cubic root of x. Everything is written here in the slides with details for you. Now, you remember the tangent line. So the line that is perpendicular to the tangent line at the point of tangency it is called the normal line. So if this is the tangent line, the line that is perpendicular on it, on the tangency point, this is the tangency point, then this line is called the normal line. Do you remember when you have two lines, what will be the slope of them? What is the relationship between their slopes? If the slope of this one is
-1.
m1 and the slope of this one is m2, what will be the relationship between them? Their product, or in other words, the first one will be negative reciprocal of the second one. So the relationship between the slopes of the normal line and the tangent line is this, that the slope of the normal line is the negative reciprocal of the tangent line. An example here, find equations. What are the equations of the tangent line and the normal line to this curve at this point? Now, if you want to find the tangent line equation, the equation will be y minus y1, if you remember, m times x minus x1. Now, m here, what is m here? M here, it is the, what is x1 and y1, first of all? x1 and y1, they are 1 and 1. So x1 is 1 and y1 is 1. So now the derivative at 1, it is the slope. Now the question now, what is f prime at 1? If you are in 2.7 or 2.8, you don't have these ideas, you need to use the definition as the quiz of today, for example. But now, if you want to find f prime at 1, just find f prime at x in general, and then substitute by 1. So look at your function here. What is our function? It is x times the square root of x. You can use the product rule, but we didn't study the product rule yet. It is easier to rewrite your function at the beginning like what? This is square root of x, so it is x to the power what? It is x to the power half. So it will be x to the power a half plus 1, it is 3 over 2. So this is y, not y prime. We didn't differentiate yet. Now this is y. Now you can differentiate. What will be y prime? Y prime will be what? 3 over 2 x to the power 3 over 2 minus 1. It will be a half. So this is the derivative now. This is f of x. Now just put a instead of x, put 1. What you will have? 3 over 2. So you will put here 3 over 2. We have it in the next slide, by the way. This is the function. This is the derivative for any x. We need just f prime at 1. So we will put this x equals to 1. So f prime at 1 will be 3 over 2 cubic square root of 1, which is 3 over 2. Now you will go to the equation that I told you to find the tangency, the tangent point, the tangent equation. So it is y minus 1. This is the derivative, x minus 1. Simplify, it will be like this. How to simplify? Multiply and write the expression in the slope intercept form. Now, what will be the equation of the normal line? The equation of the normal line will be y minus 1 equals to x minus 1, the same point. The difference will be here. What will be the slope of the normal line?
Minus 2 over 3.
Minus 2 over 3.
2 over 3. The negative reciprocal. First of all, it is 3 over 2. First of all, make it negative. Second of all, make it reciprocal. So it is the negative reciprocal of the slope of the tangent line. And of course, the remaining is just a matter of combining like terms. Is that clear, Shabab? Do you have a question about this? Excellent. Let's go now to the constant multiple rule. If you have a function multiplied by constant, then the derivative will be the constant multiplied by the derivative. Again, the derivative of a constant times a function, it is the constant times the derivative. You can bring this out like what we do in the limits. This is exactly what it says. You can prove it, by the way, by using the definition. So this is the function that you want to find the derivative for. So you will use the definition. Here it is. Let's call it g if you call it g, but no need for this step. You can go directly to here. Now this is your function. Take c as a common factor. Here it is. Now what is this? If you distribute the limit, it will be the derivative. This is according to the definition, it is the derivative. So you proved this in general. How to apply it? Look at this interesting example. What is the derivative of 3x to the power 4? Now this is a constant. Bring it out of the derivative. Now, what is the derivative of x to the power 4? It is 4x to the power 3. Now simplify. 3 times 4 is 12. So it is 12x to the power 3. طبعا you can skip this step. This step is not necessary. You can skip this step and immediately write it like that. And the last one is a matter of simplifying. The derivative of negative x with respect to x. Again, negative here, negative x, it is negative 1 times x. The negative 1 will be out, and the derivative of x is 1. So it will be negative 1 times 1, which will be negative 1. No need to do all of these steps in the future, because just you will remember that the derivative of negative x, it is negative 1. Because the derivative of x, it was 1. So the derivative of negative x will be negative 1. And the derivative of cx, for any c, it will be c. Okay. So let's take now the sum rule and the difference rule. They are the same. If it is here difference, it will be the same. This is very interesting. If you have two functions that both are differentiable, then the derivative of the sum or the difference, it is the sum of the derivatives or the difference of the derivatives. So easy. So this says that you can distribute the limit over the sum. Sorry, not the limit. It is of course coming from the limit. You can distribute the derivative over the sum and over the difference. And the derivative of the sum is the sum of the derivatives. And you can generalize or extend this to any number of functions. If you have 3 functions, 4, 5, whatever, you can distribute the limit. So f plus g plus h prime, it will be f prime plus g prime plus h prime. Now the sum rule, you can prove it, of course. If you consider the sum function to be f capital, then the derivative of the f capital will be the limit of the sum. Combine f with f and g with g, you will have, and then split into fractions. And this expression will be the derivative of g, and this expression is the derivative of f, and you prove it. The same for the difference, I told you about that. If you apply it for this polynomial, this is a polynomial, how to find the derivative? You will distribute the derivative. You will find the derivative of each term of these. So it will be equals to the derivative of the first term plus the derivative of the second, and so on. No need for this step. You can go directly to this step, ya shabab. But this is just for you to understand that there are some steps there. So you can just, what is the derivative of x to the power 8? Here it is. The derivative of 12x to the power 5, here it is. The derivative of negative 4, it is negative 4, 4, and so on. The derivative of 5 is 0. The derivative of 6 is 6. So simplify at the end. You have to simplify, and this is the derivative. Find the points on this curve where the tangent line is horizontal. This is, ya shabab, the main trick that they will use for you. It is easy. They will not ask you find the derivative of this because it is clear and easy. So they will ask you questions like this. So find the points on this curve where the tangent is horizontal. So where the line, the tangent is horizontal, ya shabab?
When the slope is 0 at the highest.
When its slope is 0. So here it is when the derivative is 0. At the points, we need to find the points at which then the derivative is 0. So what we will do, we will find first the derivative. أول خطوة تسويها تجيب الderivatives. So next what you will do, you will put the derivative equal to 0. هذه هي الدerivative. Put it equals to 0. This is what will happen if you put this equals to 0. Solve it. You have a polynomial equation. Take 4x as a common factor. Now 2 factors, the product of them is 0. So x is 0 or x squared minus 3 is 0, which means that x is 0 or positive or negative square root of 3. These are 3 points at which, or 3 x values at which the horizontal will be, the tangent will be horizontal. Okay. Now, طبعا he asking for the points. You know, in the xy plane, the points are x and y coordinates. So you need now to go back here and find what is y if x is 0, what is y if it is square root of 3 over 2. This is what you are going to have. When x is 0, you will have 4. When x is square root of 3, you will have -5. When x is negative square root of 3, also you will have -5. And if you want to see the idea, we will not do that. We will do this, ya shabab, in chapter 4. Chapter 4, we will learn how to sketch the graph of such function. So look what happened at these points. There is a maximum and the minimum values, and there is a horizontal asymptote at these points. Another example with some tricks, the equation of motion of this particle. So this is the position function. This is the position function. Find the acceleration as a function of time and find the acceleration after 2 seconds. So what is the acceleration, the relationship between the acceleration and the position function? You know that
the derivative of
acceleration
velocity.
is the derivative of the velocity, and the velocity is the derivative of the position function. So first of all, you will find the velocity by differentiating s. Here it is, with respect to t, طبعا. Then you will differentiate it again to find the acceleration, which will be the second derivative of the position function. And this is the acceleration. This is the acceleration as a function of time. Now you want to find it when t is 2, after 2 seconds. So you will just put here, instead of 2, you will put 2. And it will be, of course, 24 minus 10, which is 14. So this is the value of the acceleration function when t is equals to 2. The last part of this section is about the exponential functions. You remember, Shabab, the exponential functions, the natural one, e to the power x. Do you remember how we defined e in Math 101? طبعا you know that e approximately it is 2.7, but this is approximately. Exactly what is it? It is an irrational number. It is in fact limit when n goes to infinity for 1 plus 1 over n all to the power n. This is how we define it in Math 002. Also, we will use this definition here in the calculus, by the way. But there are many limits that their value at the end, it is e, like this one. Here, the property here, we define here e, which is Euler number. Euler number, they just take the first letter from Euler number, from Euler name, and they call it e. E is the number that it satisfies this. So if you have here x, the limit of e to the power x minus 1 over x when x goes to 0 is 1. This is by definition, ya shabab. You can calculate it numerically or graphically. So now we will use this to find the derivative of the exponential function. What is good about this function, that its derivative, it is itself. No function in the world has this property, that its derivative, it is itself. Only e to the power x, e to the power x. Its derivative with respect to x, it is e to the power x. Why and how? We will see now. Let's see how to use the definition. Now, what is your function? Your function, it is e to the power x. What is the derivative? The derivative of this function will be the limit when h goes to 0 for f of x plus h minus f of x over h. Now, what is f of x plus h? It will be e to the power x plus h minus f of x, which is minus e to the power x. Now, you have here, in fact, e to the power x plus h. It is e to the power x, e to the power h. You know that. So this, you can take e to the power x as a common factor. So it will be limit h goes to 0 for e to the power x times e to the power h minus 1 over h. Now, the limit of e to the power x when h goes to 0, it is e to the power x. It does not depend on h. Now, what is the limit of this when h goes to 0? Here it is. It is 1. So you have e to the power x. The derivative of e to the power x, it is e to the power x. Now, you should ask yourself, what about if it is not e? If it is, for example, 2 to the power x or 3 to the power x? We have it here, e to the power x, a to the power x, for any a greater than 0. Of course, it should be mentioned here, yes. For any a greater than 0, the derivative of a to the power x, it is a to the power x, but multiplied by ln a. In fact, we have here, we have e to the power x ln e. But what is ln e? Ln e is 1. So it will be e to the power x. We will not focus on that one now. We will focus more on it in 3.4 about this. Here we need to focus on e to the power x. if this is your function, find the first and the second derivatives. So the first derivative, it is what? What is the derivative of e to the power x? It is e to the power x minus 1. The derivative of x is 1. This is the first derivative. The second derivative, you will differentiate this again. The derivative of e to the power x, it is e to the power x. And the derivative of 1 is 0. So it will be e to the power x. If you differentiate it forever, it will stay e to the power x. This is why most of the students will like this function, because if you integrate it or differentiate it, it will stay the same. But I'm talking e to the power x. You may have a number here, no problem. Also e to the power x, if you differentiate it, it will be e to the power x plus 2. Okay? But if you have e to the power x squared, this will not be the derivative. The derivative will not be e to the power x squared. We will see that in a 3.4 when we study the chair rule. So be careful, you need to apply the chair rule there. It will be, by the way, if you are interested what it will be e to the power x squared, but you need to multiply by the derivative of this, which is 2x. It will be like that. Do we have another example? Yes, we have the last example. Again, these are the kind of tricks that you will have in the quizzes and the exams. This question. At what point on this curve the tangent line is parallel to this line? So
Same slope.
the slope here is 2. What is the slope here? Is the derivative. So these should be equals. E to the power x should be 2. So x should be what? Len 2.
Len 2.
Take len for both sides. So what is the point? It is len 2 and what? Len 2 and both here x equals to len 2. What you will have 2.
2.
So the point that at which you will have a parallel tangent line to this line, it is len 2 and 2. That's it. That's it, yes, this is what we have. These exercises that are suggested for you to solve, and these are some old exams. You have many old exam questions, yes, I am doing a lot of effort, by the way, to prepare the notes and to add these old exams for 2 courses, for MATH101 and MATH102. So can you tell me, please, yes, what is f prime at 1 here? We still have 1 minute. If you don't, it's okay. You can practice it at home. Who can tell me what is the derivative of this? With respect to x, طبعا. If a prime here. It is 3 pi. 3 pi is constant.
Yeah.
The derivative of e to the power x, it is e to the power x. Now negative 2e, negative 2e, x to the power pi. What is the derivative of x to the power pi? It is pi, x to the power pi minus 1. What is the derivative of this?
Zero.
Yes, who said 0?
يزيد.
أحسنت يا يزيد. You have a bonus يا يزيد.
Thank
This
you.
is 0 يا شباب. ليش؟ لأنه constant. في x هنا، أنتم شايفين x يا شباب؟ Is there x here? There is no x. So the derivative of this is 0. So it will be plus 0. بعدين عوض بدل الاكس ب 1. That's it يا شباب. We are done for today. Thank you very much يا شباب, and see you inshallah next class. Yes.
3 باي